Okay, so the next concept that you will have to that you'll encounter a lot is in statistics what we call as distribution. Okay, you will see this picture a lot. It's a normal distribution. Okay, now let's try to understand this from the basics as I've been doing so far, which is we take this dot example. If you remember, you throw this dot a million times, and what you do is you record the distance it falls from the center. You take this long book and record every distance, right? Now let's do something simple with that. You record the distances and put the frequency here. The frequency is number of times you hit that distance. So what I do is I take 0, which is the center, and I count how many times did I hit the center. Let's say it's 50,000. Okay, and then I count how many times was I to the right of it by 1 inch. Okay, and let's say it's 45,000. How many times was I left of it, and let's say it's 40,000. So if you keep taking this numbers, which is anything between 0 and 1 is considered 1, anything 0 and minus 1 is minus 1, 1 to 2, 2 to 3, and just look at how many you see. Okay. You will get something like this. Your picture will look something like this. 9, 8, 7, 6, 5, 4, 3, 2. Right? If you see this picture, it looks very much similar to that one. So all that this normal distribution is saying is that for a thing that occurs many times, we're trying to plot how many times does it take the value 0, how many times does it take the value 1, how many times does it take the value 2 and 0.5, and the point here represents, like, let's say this is 1, this is how many times we actually hit the value 1, exactly 1. Okay, so it so happens in nature that most of the distributions are normal distribution. So when you're throwing a dot, you will invariably find that the more often you do it, the more it will look like this. Your distribution will look like this. If you do it 10 times, you won't be able to make much, but when you do, that's why we made you do it a million times. The more you do it, the more it will look like this. When you take the distribution, what does a distribution mean? Very simply put, it is again a relationship between okay, what's a distribution again? Just to emphasize on the basics, is it's the relationship just like we took before, but it's a relationship between a thing, the value that a thing takes, and how many times does it occur. Maybe I'll phrase it in one more way. When you're throwing darts, a distribution of these darts is, one way to look at it is, how many times does does your dart fall in 1 inch? How many times does it fall in the 2-inch range? How many times does it fall in the 3-inch range, or 2 to 3, 3 to 4, 4 to 5, etc., etc. So that's when you plot that, like the more you do it, the smoother this curve gets. Instead of being jagged like this, it will become smoother and smoother. After a very large number, it will look like a normal distribution. So when people found that all these events that happen many times, they tend to look like a normal distribution, they said, okay, we'll study this distribution in detail and use those properties to figure out a lot of things about our dot show here. You can tell a lot. That's pretty much all there is to statistics. Now, I can ask you a simple question, right? Which is, how often does your dot fall between 0 to 7 inches? Okay, so how do you do that? Let's say this is the normal distribution, 3 inches, 4 inches, 5 inches, 6 inches, 7 inches. So pretty much what you're saying is we want to find out, this is minus 7, minus 6, minus 1, minus 2, minus 3. So how do you calculate that? Okay, what we know is that This is the number of times it fell at 7 inches. This is the number of times it fell at 6 inches. This is the number of times it fell at 5 inches. Now, all we have to do is take 7 times this height plus 6 times this height plus 5 times this height plus 4 times this height, blah blah blah, do it until 7 again. Okay, and if you know calculus, there's this very interesting property called integral, and it gives you the same value. Or an integral is basically the area under this curve, this whole thing. So if you integral, let's say this function is called f of x, integral of f of x from -7 to 7 gives you this area. Okay. Now this is a very complicated function to calculate, so that's why you get these ready-made tables. And in the ready-made tables, you can have this x value, and you can find the shaded region. They just compute it beforehand and give you the tables. So that's pretty much how I understood statistics.